Hello, in this tutorial you will learn simple thresholding, adaptive thresholding and auto thresholding. The assignment of pixel values in relation to the specified threshold value is known as the thresholding technique in OpenCV. Each pixel's value is compared to the threshold value during thresholding. Here I wrote some Python code to show you how thresholding works. There is a picture here, it's a Sydney picture. To apply threshold, I wrote 0 to CV2 and read because of this. 0 is required for thresholding. In this line I used simple thresholding. The method is straightforward. For every pixel the same threshold value is applied. If the pixel value is smaller than the threshold, it is set to 0. Otherwise, it is set to a maximum value. The function CV threshold is used to apply the thresholding. The first argument is the source image. Which should be a grayscale image. The second argument is a threshold value, which is used to classify the pixel values. The third argument is the maximum value, which is assigned to pixel values exceeding the threshold. OpenCV provides different types of thresholding. Another thresholding is called adaptive thresholding. In the preface section we use one global value as a threshold in thresholding method. In adaptive thresholding might not be good in all cases. So if an image has different lighting conditions in different areas, simple thresholding doesn't work. In that case, adaptive thresholding can help us. Here the algorithm determines threshold for a pixel based on a small region around it. So we get different thresholds for different regions of the same image, which gives better results for image with varying illumination. The method CV adaptive threshold takes 3 input parameters. In adaptive thresholding method there are 2 types. One of them is adaptive thresh mean and the other one is the adaptive thresh Gaussian. The threshold value in the adaptive thresh mean is the mean of the neighborhood area minus the constant C value. In the Gaussian version, the threshold value is a Gaussian weighted sum of the neighborhood values minus the constant C. The block size determines the size of the neighborhood area, and C is a constant that is subtracted from the mean or weighted sum of the neighborhood pixels. Another techniques I would like to talk about is auto binarization technique. In global thresholding, we used an arbitrary chosen value as a threshold, as I mentioned before. In contrast, in Otsu's method, it avoids having to choose a value and determines it autonomically. Consider an image with only two distinct image values, where the histogram would only consist of two peaks, right? A good threshold would be in the middle of those two values. Similarly, Otsu's method determines an optimal global threshold value from the image histogram. In order to do so, the CV threshold function is used, where CV threshold is passed an extra flag. The threshold value can be chosen arbitrarily. The algorithm then finds the optimal threshold value, which is returned as the first output. Now I will show the results in this lines. I basically open the plots section to show you how images are affected from each for algorithms. To run the code, okay, we have to use Python 3. And I use thresholding, as you see. The results are what I explained. In this video, I talk about thresholding. I showed various methods in this video. Thanks for watching my video. Don't forget to subscribe and